particular folder, the title at the bottom says Raising Powers. So you're going to have three different situations where you'll have parentheses and you'll have a power on the inside and a power on the outside. So when you're raising a power to a power, you actually are going to multiply the exponents. So you cannot get it confused with the product rule. So a good hint here would be if you see an exponent on the inside, you see parentheses, and you know parentheses basically represents multiplication anyway, that you're going to be multiplying the two powers together. Okay, so to raise a power to a power, keep the base and multiply the exponents. So let's just go over some basic examples. I'm going to have you add some additional examples in a few minutes. So just make sure you're paying close attention. So x to the third raised to the fourth, you see a power on the inside and outside. So you basically multiply those powers together. Okay, and 3 times 4 is 12. So x to the 12. Okay. Same thing for number 2. 7 times 5 is 35. Okay, so that's the basic foundation there of just multiplying the inside and outside powers together. Okay, power to a product. So that means if you have more than one thing inside of those parentheses, okay, so that means both factors have to be multiplied by the power on the outside. So let's take an example. So notice I have not only just a G, I have an F and a G. So everything has to be multiplied by 7, including the F and the G. So 7 times 3 is 21. 7 times 5 is 35. So what if there's a number also inside? You do the same thing. That 4 has to be multiplied by the exponent. Remember, there's like an invisible 1. That's like 4 to the first power. So you're going to say 4 to the third power, and that's how we get the 64. And then you multiply the 2 times the 3 and the 9 times the 3. So everything has an exponent, so everything has to be multiplied by the outside power. Okay. Any questions on that? So let's take a look at number 7. So same thing, you're going to be raising the 2 to the 5th power, and you can do that right on your calculator. 2 to the 5th power will give you 35, and then you multiply your 4, you multiply your 3 also by 5. All right, so here, when you raise -5, and again, all of -5 to the second power, that's going to give you 25. And then when you multiply, 6 times 2 is 12, 1 times 2 is 2 for the y, and 8 times 2 is 16 for the z. All right, so let's move on. So now, what if you have a fraction, and you have it in parentheses, and you have this power on the outside? So you basically will treat them individually, the numerator and denominator, and still multiply the power. So the rule doesn't change if it's a fraction. Everything inside of those parentheses still has to be raised to the power. So again, this x has a power of 1. So when you multiply 1 times 6, you get 6. This also has a power of 1. So when you multiply 1 times 6, you get 6. Okay, so remember, you're multiplying, you're not adding. So same thing if there's a number in here. So you're going to raise 7 to the second power. It's not 14. 7 times 7 is 49. You're going to be raising the b because you're going to multiply 1 times 2. Same thing for the c. You're going to be multiplying 1 times 2. So your answer is 49, b to the second, c to the second. All right, I'm going to have you guys try number 11. So raise 5 to the third power and multiply the other exponents and see what you get. All right, so you should have 5 to the third power is 125 Multiply your J's, 12. Multiply the K, you get 21. Okay. All right, last one. Okay, try this one as well, and I'll see what you get in a second. Okay, all right, very good. So we're going to have 3 to the 4th power is 81. Multiply your m's, 20. Multiply your n's, you get 8. Now, we're going to add some additional ones because that's just the basic, so you can kind of understand what you're doing with those exponents inside and outside. So let's add some additional ones. If you cannot fit them on your foldable, then by all means use your notebook. Okay, but these are some additional examples because you'll see some additional types of problems on your worksheet for today. So let's say you had something like this: y times 2y to the 3rd times y to the 4th, and let's say all of that is raised to the negative 3rd power. Because it doesn't say that your exponent on the outside has to be positive. So what if there's a negative exponent on the outside? Now you can do this two ways. What I would do first, since I have all of these y's inside of the parentheses, I would actually perform what's inside of the parentheses first before multiplying it by that negative exponent on the outside. Okay, yes, you could take each little thing inside and multiply it by -3. Okay, or you could do this. That means simplify what's in here first and then raise it to the negative 3rd power. So I'm going to go ahead and multiply this. So now I'm using my product rule, which says I add these exponents together. So the 2 doesn't have anything else to multiply it by, so that'll stay 2. Okay, I'm going to add my y's. I have 1 here, 3 here, that's 4, and then 4 plus 4 will give me what? Okay, so I have just narrowed this down to 2y to the 8th, all raised to the negative 3rd power. Okay, so now I'm going to use that raising the power rule, which says now since I have this on the outside, I'm going to multiply the powers together. So that'll be 2 to the negative 3rd, y to the negative 24. Now keep in mind, you cannot leave negative exponents in your answer. So now we're going back to the rule that we learned previously where it says you have to take the reciprocal in order to make the exponents positive. Okay, so this 2 to the negative 3rd is going to drop down to the denominator. The y to the negative 24th will also drop down to the denominator. So this is how all of these laws of exponents tie together. Okay, because if you have negative exponents when you're done, you have to use your negative exponent rule. Now, of course, you're going to say 2 to the 8th power is, 2 to the 3rd power is 8. And so this would be your final answer. Okay, 1 over 8y to the 24th. So I don't want you to think that you're going to always be dealing with positive exponents on the outside. If you deal with negative exponents, then you're going to obviously have to take the reciprocal. All right, let's take another example. All right, so let's just take this one. This is a positive exponent. Okay. So here I'm applying that same rule that we just finished doing, the raising to a power. So remember, this has a 1, this has an invisible 1, that has an invisible 1 there. So 3 to the 1st power, I multiply 1 times 3. That's going to give me 3 to the 3rd, x to the 3rd. And at the bottom, it's going to give me 2 to the 3rd, x to the 12th. Okay, so obviously I have to say what 3 to the 3rd power is. What is 3 to the 3rd? 3 times 3 is 9. 9 times 3 is 27. And then I'm going to do 2 times 2 is 4. 4 times 2 is 8. All right. And now I'm going to subtract. Now here's my quotient rule. So I have these x's here. So now I'm going to subtract them. So when I use my quotient rule, which says I subtract these, well, what is 3 minus 12? Negative what? 9. So I'm going to put it down here so it becomes positive 9. And there's your answer. So now you have to be able to apply all of these rules, and you are going to be applying more than one rule in one problem. Okay, so see how we use the raising to the power rule first, and then after that we had to use the quotient rule because we had to simplify the x's. All right, so one last example. All right, so what if I just had this 2 over x to the negative 3? Now, since all of this is going to end up being negative, you can do this one two ways. So I'm going to do it two different ways. First, I'm just going to go ahead and multiply and get 2 to the negative 2 over x to the negative 2. Okay, and now I know that since both of these are negative, I need to really take the reciprocal, bring this to the top, bring this to the bottom, and then I get x squared over 4. Okay? And you could also approach it this way. Since all of this is being raised to the negative second, you could then flip the whole thing at the beginning, like this. And now it's positive. Okay? You can do that. So you can flip the whole thing at the beginning, make it positive, and then you end up with x squared over 2 squared, which is 4. So that's just an optional way, because if this negative is out here and everything in here is going to end up being negative like we did in the first example, then you can flip or take the reciprocal of everything inside and then just make that a positive exponent on the outside. So that's just an option. If you want to leave it like it is and then just go ahead and say 2 to the negative second and x to the negative second, and then flip it at the end, that's totally up to you. But I just want you to know that is an option.